Hello, I am recording this session to go over questions that you might have from the practice exam, maybe review a couple of concepts, and just hopefully have people well prepared for exam number 1. First off, just as a strategy, I really want to encourage you to make frequent reference to the equation sheet. I had some problems making this particular equation sheet where things kind of got mashed together. Your equation sheet for the exam will have these equations spread out a little bit more. But the equations of kinematics, you probably have, at least a functional definition in your brain for each of them. I'll just encourage you not to rely on that exclusively. If you, just kind of have a little brain freeze while you're taking the exam. If you use the wrong equation, you're going to get the wrong answer. So you have all the right equations, make sure you reference them. One piece that we did asynchronously was the discussion of a box on an incline. And I just want to take a moment to kind of go through. So we have a box sitting on an inclined plane. Gravity pulls straight down toward the center of the earth. That's the mg, that's the weight of the box. But the box can't move straight down toward the center of the earth. It is constrained to slide down an inclined plane. So it's only a component of its weight that is pulling it down the inclined plane. And that component is mg sine theta. That's what pulls the crate down the plane. And then the other component of the weight would be opposed by the normal force. That the normal force is mg cosine theta. Therefore, friction is coefficient of friction, static or kinetic, I don't know which, times the normal force. Coefficient of friction times mg cosine theta. So the net force on the incline for this kind of situation is the force that pulls it down the incline, mg sine theta, minus the force that resists that pulled down the incline, coefficient of friction times mg cosine theta. So this may be the punchline that we're getting to whenever we have a problem on an inclined plane, but just make sure you are familiar with the components, all the pieces that go together there. Newton's second law, force equals ma. When you're standing on a scale on an elevator, the normal force, the weight that the scale reads, is going to be your true weight, mg, plus ma, mass times your acceleration. So if it's an upward acceleration, the normal force, the scale is going to read higher. If it's a negative acceleration, it will read lower because a will be a negative value. Static friction, kinetic friction. We have all our terms that we will be using, and just make sure that you check in on the equation sheet when you're trying to do a problem, so that you will be able to know, have ready reference to the actual equations, maybe not something that you kind of put in your head and just might be a little confused about. As you go through the practice exam, some of the questions are pretty straightforward. You have something that's moving at 0.037 meters per second for 120 seconds. So you want to find the distance, and it's distance equals velocity times time. But with this question number 1, we're going to find out which one went further. So there's another step. It's not just plugging numbers straight into your calculator. It's to figure out how far the tortoise would travel, how far the sloth would travel, and then how much further the tortoise traveled than the sloth. It's you know, multiple steps there. So, you know, just be prepared to think about all the, I know it sounds kind of trivial, but make sure that your answer that you give is answering the question. So go back to the question and make sure that the number that you have at the end is the response to the question. It's easy to get, you know, caught up in the details and just kind of lose sight of, you know, specifically what it is you're trying to answer there. What else do I definitely want to say? There's other things that I definitely want to say. The football question is on the exam. Much in the same format it was in on the quiz the other day. I meant to post a video key to the second quiz, and I have not done that yet. So I will post that. It's a video walkthrough of me answering those questions. I don't think I did it. I meant to do it. Number 19 is one of those questions that is from the more recent material that that I think might be a little confusing to people. So I just want to run through the steps for this problem quickly. This problem is something on an inclined plane. So I guess we have a person sliding down a slide at a park or something. So a person sliding down. When we go back to page 1 of the exam with the equation sheet, we have a picture at the bottom that describes that the accelerating force down the incline is mg sine theta, and it accounts for the normal force being mg cosine theta, which means the frictional force, friction is always going to be the coefficient of friction times the normal force. So the net force on the inclined plane, incline, equals mg sine theta minus coefficient of friction times mg cosine theta. So this question is only asking what are the magnitudes of the normal force and the accelerating force. So the normal force, mg cosine theta. So normal force equals mg cosine theta. That means 60 kilograms times 9.8 meters per second squared times cosine of 35 degrees. Do run these things through your calculator as you're doing the practice exam, just to make sure you get the same numbers that I do, because it's easy to just have your calculator in radians instead of degrees, and suddenly you're getting different answers and you don't know why, and you want to make sure you're getting the right answer. So the normal force here is 482 newtons, and the accelerating force, that's what I call the force that compels the person to slide down the slide, is mg sine theta, same m, same g, same theta, but now it's sine instead of cosine. So 35 sine times 9.8 times 60 is 337 newtons. Same kind of process here on number 20. Nope, it's not. Different process because it's a sled on a horizontal surface. So that's a totally different question. And again, there's a lot of information there. It's a sled and it's got a velocity and it's got a something else. And some of that information is irrelevant to the question that's being asked. This number 20 question could be a lot more complex. I would use a version of number 20 on exam 2, perhaps, where we're dealing with impulse and momentum. But we're not ready for that yet. We're not up to impulse and momentum. So this is just asking, what is the frictional force? Frictional force is, it'd be kinetic friction. It's the coefficient of kinetic friction times the normal force. This is a sled on a horizontal surface. So the normal force on a horizontal surface, oops, is just equal and opposite to the weight, unless there's some other force taking place here. And they didn't describe it to us if it is. So Fk equals coefficient of kinetic friction, 0.25 times mg, 50 kilograms times 9.8 meters per second squared. I have had students take exams, and for reasons where they have put in significant effort to try to hammer home what's going on in physics and have an incomplete understanding, which, you know, happens along the way as you're developing an understanding of material. And when I would say the plane will accelerate at 1.8 meters per second squared, a student would cross out 1.8 and write in 9.8, because I told them that anytime there's an acceleration, it's the acceleration due to gravity equals 9.8 meters per second squared. And I didn't tell them that. That's not the case. This is an x-axis acceleration of 1.8 meters per second squared, as opposed to something in free fall motion. So don't make that mistake. These things can happen. I don't know what other questions you might have. If you want to unmute and ask a question, or if you want to type something in the chat, I will find it and answer those questions. Overall, it's important that you not panic. There's no reason to have extra stress that always makes it so you don't think as clearly. Deep breath, calm. You have plenty of time to take the exam. And on Wednesday, on exam day, I will be here on Zoom chat. If you're like, wait, I'm just not quite sure what number 7 is asking me for. Those kind of clarifying questions, I have no hesitation to answer. Sometimes people are like, so if I use this equation and do this and do that? Is this going to be the right answer? And, you know, at some point I'm not evaluating your understanding if the chat question is, you know, is this the right answer or not? But sometimes I feel justified in saying, oh, I think you might have left out a step there, or maybe you should take another look at it. And that can work out fine. So as you're taking the exam the first time through, ask me questions. I will try to clarify and get you moving in the right direction. Yeah, no, that's it. Then the second time you can take the exam a second time, we'll keep your average score. The second time through is open book, open note. So any resources that you think you might need to help you get the answer would be available to you. And, you know, the point isn't to, you know, have you, look at the answer and write out the answer. Like, that's not cool. But the point is to, you know, give you the resources that you might need to, you know, get over the hump, you know, figure out what it is that you were missing maybe the first time you took it. Let me stop share and so I had forgotten to add the quiz key. So edit. Quiz number 2 on chapter 3 key. So as you're preparing for the exam, do go back to last week. I have the key to quiz number 1. Is that in week 1? Ooh, that make me mad. I think I posted. Oh, all right. So if I didn't, I will get that one posted as well. But, you know, here's the video key that I just uploaded for quiz number 2. And hopefully that is helpful to you to watch me work through it step by step. All right. See a chat question. I'm gonna go to the lab in just a second. Want to double check. For every chapter, I have a video that I made of a fully disembodied walkthrough of the material, just kind of clicking through the PowerPoint and talking through it. So there is, I broke chapter 5. Oh, there's 2 there. So chapter 5, you know, the video walkthrough, I think these are both the same thing. But I also have a actual lecture time with my floating head going through. Oh, here's chapter the quiz on chapters 1 and 2. I have one with my floating head talking through through chapter 5 material, which was an actual lecture from February 24th that I did during the semester. Some of the labs are you can take a picture or save what you do as a PDF, and you can upload it in the lab space itself. And others I have kind of devised as a question that you'll ask. So I'm getting a question on question 4, page 11 of lab 3. So let me take a quick peek at that. So the table below shows the acceleration of a 50-kilogram crate in response to applied forces. Identify which acceleration should be used in the missing spot. So I don't know that they're claiming that it's uniform, but I guess it doesn't even particularly matter. So force equals mass times acceleration. That is Newton's second law of motion. So acceleration equals force divided by mass. So force of 1 Newton divided by 50 kilograms. To apply, identify which acceleration should be used. An acceleration, shows a 50-kilogram crate. So none of these make sense with this mass, right? Applied force of 3 newtons divided by 8 means there's already some, or 3 divided by 50, there's already a certain amount of force, and then we're adding this applied force. So if we want to figure out what the total force is, what's going on, how much more acceleration this applied force adds, we need to figure out the baseline amount of force. So acceleration of 8 meters per second squared is going to equal force minus 3 divided by 50. 400 equals force minus 3. So the force equals force plus 3. Force minus 3, 397 newtons. Is that going to work for everything? 5.33 equals force plus 2 divided by 50 kilograms. 50 times 5.33, 50 times 5.33 is 266.5 equals force plus 2. So the force would equal 264.5. Those are different. Something looks really messed up about this, and I'm missing it right now. If it was just vanilla, I would say that it should be acceleration equals force divided by mass. So 0.5 divided by 50 kilograms. 0.5 divided by 50 would be 0.01. If there's some baseline force, it's not clear to me what that baseline force is. Let me scroll up a little bit. Am I missing something? No, I'm sorry about that. That question seems a little messed up to me. Did not mean to cause more confusion than I would clear up and address. So that's always a bad thing. So I will be giving credit whatever your answer is on number 4 on this lab. Sorry about that. All right. I'm not seeing more questions yet. So do people have any other questions? I'll try to be more effective in answering. I did make a video for lab number 4, walking through the process for answering that particular question. So that is here. If you already did lab number 4, maybe you did it before I put in the video, but just kind of walking through the process. This is another kind of question that we could address in multiple different ways, but we have a simple pathway that we'll use for right now with kinematics. Okay. Any other questions before we part ways today. On Wednesday morning, I'm going to talk a little bit about chapter 6, just kind of set the stage for what's going to be coming after the exam. But then I will bring us all back to focus on any last minute questions for exam number 1, and then have you go for it. So, and I'll be here while you're doing it. So, and I will post this video right here as soon as we're done recording it. Any other questions? You feeling okay? I hope you're feeling okay. This is fun stuff. You just gotta kind of get into the habit of like picking out the key variables, list your knowns and your unknowns. Do that even though it seems a little tedious. When you list your knowns and unknowns, you can find that variable that you have no information on. Look for the equation that doesn't have that variable in it, and that's the right equation to use. Double check that you're actually answering the question that was asked, and you will be in good shape. All right. That will be all for today. I will see you on Wednesday. I'll be here. See you.